I am going to tell the potential due to the uniformly charged sphere. So let us consider a sphere. This is a sphere of uniformly charged, positive charged. This is the center of the sphere O, and the radius of the sphere is capital R. So we will calculate the potential at R greater than R, R equal to R, and R less than R. So we have to calculate the potential in 3 points. Now let's start. Case 1. Case 1 is for R greater than R. Okay, so let us consider a point O, point P for P at a distance R, and R is greater than the radius of R, which means the outside of the sphere. We have to calculate the potential at the outside of the sphere. Okay, so everyone I think knows the Gauss law. So close integration E dot ds equal to q enclosed by epsilon naught, or we can say also d dot ds equal to q enclosed. D is the electric field density, or epsilon naught, or D you can write epsilon multiplied by E. Okay, so now consider, so this is a sphere of positively charged, radius is R. Now consider a Gaussian surface of spherical shape at radius R. So we know close integration E dot ds. What is the surface area of this Gaussian surface? Will be 4 pi r square equal to q enclosed. What is the q enclosed? Q enclosed is nothing but the total charge enclosed by the Gaussian sphere. So total charge enclosed is nothing but the total charge q in this sphere. So we can write q. If the charge in the sphere total charge is q, then we can write q. So we can get q by epsilon naught, is the flux. E equal to q by 4 pi r square into epsilon naught, right? This is the E, electric field. Now what we know from the definition, potential at any point is equal to my integration of line integral of infinity to that point E dot dr, right? So now I am putting the value of R, value of E in this place. Epsilon naught dot dr. So this is in the same direction. Dr and the R is in the same direction as electric field, and the dr is, or the displacement, small displacement is in same direction. So dot dr means cos theta. Cos theta value is 0. So we can write like this. Okay, cos 0. So we can get this expression So after this, let's go to next slide. So we got minus of integration to r q by 4 pi epsilon naught r square dr, right? Now we can take q by 4 pi epsilon naught as a constant outside of the integral. We'll get dr by r square. So we can get what is the value? Minus integration of 1 by r square minus 1 by r, and the limit is infinity to r. So now what is the value? Now this negative will be cancelled. 4 pi epsilon naught 1 by r minus 1 by infinite. So q by 4 pi epsilon naught into r minus q by 4 pi epsilon naught infinite. So this is not for a potential at infinite distance at r equal to infinite. So we consider v infinite is equal to 0, and from here you can also see that this term will evaluate to 0. At is some finite divided by infinite will always give the value 0. So we can see, so what is the potential? 4 pi epsilon naught into r plus, sorry, not plus, minus 0. So we can say this is equal to Vr equal to q by 4 pi epsilon naught into r. So here we can see the potential at distance r outside the charged sphere is given by q by 4 pi epsilon naught into r. So V is inversely proportional to r. From here we can see. Okay. So now consider for V r equal to r. So in same r equal to r, the potential is equal to q. Just put the value r at here, we will get 4 pi epsilon naught into r. So V at r equal to r bigger means the radius or the surface of the sphere, the potential will be q by 4 pi epsilon naught into radius of the sphere. So now next come to next slide. So now we are calculating potential for r less than r, means inside the charge sphere. As we know, so this is a charge sphere of radius r. So for less than r, we are drawing a Gaussian surface or spherical of radius small r, right? So in this small r, we know same close integration d dot ds equal to q enclose, right? So d, what is the ds over here? D dot ds is equal to, so this is the closed integration over the ds, so it will be equal to 4 pi r square. This is the sphere, so this is the sphere surface area equal to q enclosed. Now we know the charge sphere has total charge q. So what is the we have to find the charge enclosed in this small radius or this Gaussian surface, inside the Gaussian surface. So we know we have to find the charge inside this Gaussian surface. So we know that if the charge density, volume charge density will be given by q by 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of this sphere. Okay. Now this rho we multiplied by the volume of this small sphere or the Gaussian sphere will give the charge inside the Gaussian sphere. Okay, so it will be 4 by 3 pi r cube. So q by 4 by 3 pi r cube multiplied by 4 by 3 pi r cube. Now this cancel, so what will be the value? Q r cube by r cube. This is the value of charge enclosed by the Gaussian surface. So next, go to next slide. So now we are just putting epsilon naught into E dot ds equal to q enclosed, we know. So now epsilon naught, we are taking out constant to E dot ds equal to, what is the value of enclosed charge? Q into r cube divided by r cube, right? So this will be value of q of u into dot ds equal to 4 pi r square to, and get this value. So epsilon naught into E, you can see we can cancel this r cube, r equal to this q, epsilon naught into E equal to q 4 by r into r cube. So E equal to q into r 4 pi epsilon naught into r cube, right? This is the value of the electric field inside the sphere at r less than r. So now we know the potential. We have to find the potential at r. So what is the definition of potential? Potential is the work done to bring a unit positive charge from infinite to that point. For example, this is P. So now we have the work done to bring a unit positive charge or unit positive point charge from infinite to this point. So we know the electric field outside of the sphere is Q divided by, what is the value? Q divided by 4 pi epsilon naught into r square, right? Electric field outside the sphere, and the inside the sphere, what is the value? What is the value? Q into r, this value, Q into r 4 pi epsilon naught into r cube. So you see at the surface of this sphere there is a discontinuity of the electric field function. Okay, so we have to calculate the potential or the work done from infinite to the surface to boom a unit positive charge, and then again from surface to this point inside, because the electric field is changing its value. So we have to calculate break the limit from infinite to the surface of the sphere, and then again surface to the point where we have to find the potential inside the sphere. So generally it will be given by my infinite to r E dot dr, where r is less than r. Now we have to break the function, so we have to calculate the potential at different, or the work done from infinite to r or the surface of the sphere, minus E dot dr, we are breaking the limit, minus r2 small r, which is the from the surface to the small r or the inside of the sphere, E dot dr, right? So we know we have already find this function. This is nothing but just the potential at the surface of the sphere, of the charge sphere. So what we have found, the surface of the charge sphere, potential q by 4 pi epsilon naught into r. So this is equal to q by 4 pi epsilon naught into r. Now for here we have to put the value of the electric field inside the sphere. What is the value? Q into r divided by 4 pi epsilon naught r cube into dr, right? So q by 4 pi epsilon naught into r minus, now you can see we can take this 4 pi epsilon naught outside, okay, r to r dr divided by r cube. Okay, sorry, this will be r. So this r is also constant, we can take outside of it. So 4 pi epsilon naught r cube. So what is the value of integration? R square by 2, value r to r. Okay, let's go to next slide. So what we got? Q by 4 pi epsilon naught into r what is it now? So here we just putting the limit q 4 pi epsilon naught to r cube into r square by 2 minus r square by 2. So it will be q by 4 pi epsilon naught to r minus, if we do this, q into r square 4 pi epsilon naught into, sorry, it 2 will be multiplied, so it will be 8 pi epsilon naught into r cube, and it will be q to r square 4 pi epsilon, sorry, again it will be 8 pi epsilon naught into r cube. So this square and this cube will cancel, so it will be q by 4 pi epsilon naught to r. We can just add these two terms, plus q into 8 pi epsilon naught into r minus q into r square by 8 pi epsilon naught into r cube. Now we can just add, it will be 8 pi epsilon naught r 2q plus q minus q r square by 8 pi epsilon naught into r cube. So it will be equal to 3 by 8 pi epsilon naught r into q minus q r square divided by 8 pi epsilon naught to r cube. We can take 1 by 8 4 pi epsilon naught r common, so it will be equal to q minus q r square divided by r square. Let's go to next slide. Actually this is too hazy over here. So it will be equal to 1 by 8 pi epsilon naught into q 3q by r minus q r square by r cube, or we can also take q and 1 r common, 8 pi epsilon naught r 3q minus q r square by r. So this is the potential at a distance r less than r. So hope you understand this video. So thank you for today's class. So hope you see in the next day. Thank you.